I don't know how long I'm going to talk because I don't know. Like, it can go on for hours. It can be over in 10 minutes. Title of my sex tape. So my slides give a very basic overview of the approach I took to solve the problem of my master's, which is, can battery life on mobile devices be conserved by using the cloud? I just jazzed that up a bit for you guys. Okay, so what are mobile devices? You know, the thing in your phone, thing in your pocket, your phone, you run the apps, it's got battery, it's got a screen, basically a mini computer, and it has access to the internet. It has access to the internet. So the problem with mobile devices are they're battery powered, which means as soon as the battery's dead, the phone's dead, which means no more porn. Let's call a spade a spade. So there are three components, that consume most battery life on your mobile device. The first is the screen, and aside from tweaking your brightness settings, there's not a lot you can do to reduce the power used by your screen. The other two, communication and computation, which is communication, that's uploading, downloading, using the internet basically. It's powering the little radios on your device that communicate. Pretty straightforward, right? Computation, that's making your phone do anything.
Trying to get rid of the feedback where we might be. Yeah. Be addicted.
I don't know. I forgot to turn on my slides, my Kazam.
Oh, you're on mine. Mine's
Oh, that's cool. So, communication. Mobile devices can connect to Wi-Fi, 4G, 3G, HSPDA, Bluetooth, infrared, NFC. There was a list. There was a longer list. I had a longer list. It just didn't fit on the slide. And then it stands to reason, the longer you power this radio, which means the longer you're communicating, the more battery life you're using. This is an interesting graph. It shows how long it takes a phone to go from 100% to dead when downloading over Wi-Fi, uploading over Wi-Fi, downloading over Bluetooth, uploading over Bluetooth, 3G. Yeah, downloading and uploading over 3G. So, as you can see, Bluetooth, it's the red one. You can do that for about 10 hours and nothing else, and your phone will be fine. Just don't do that. That's stupid. Computation. That's using the CPU on your device. Computation takes battery life, because it has to power the CPU. More complex tasks take more calculations take longer to execute. The longer execution time consumes more battery life. I mean, this is all pretty straightforward. I have bunches and references if you want to, where this is proved. I don't know. Yeah, what she said. So that brings us to a completely new topic, which is the cloud. I need a buzzer for buzzwords. So the cloud has got all the resources, where your phone has only got some resources. So when you connect to the cloud, you have access to more processing power, you have access to more storage, you have access to more RAM, all the things. And you get to the cloud through the internet. Who knew? So that brings us to mobile cloud augmentation. That is using the resources on the cloud as if they're on the phone. Offloading, RPCs, Virtualization, which is something that's really not, you shouldn't don't go looking into that. So from the phone through the internet, you go to the cloud and you get the resources, which brings you to the choice. Either you compute things locally or you communicate all the data necessary to the cloud, have them compute it, and send back the result. Which brings us to decision making. You need to decide between computing and communication, depending on what your goal is. If your goal is to conserve battery life, you need to choose the option that uses the least amount of battery life. If the option is, if your goal is to have this run as fast as possible, you choose the option that is fastest. And if you want the one that costs the least amount of money, you need to pick that one, obviously. I mean, all of this is pretty straightforward. Nobody's just ever done it, documented it. And then the factors that influence this decision is network availability. Because as you saw, the network you are connected on determines how much battery life things are going to cost. And the complexity of the task determines how much local execution is going to cost. Now, this battery life consumption estimation, very tired of this. I'm triggering myself by doing this. This is basically, you guess or estimate, I went for guesstimate, how much power a given task is going to take. Given the current network the phone is connected to, how much battery life will be consumed if I offload this? How much battery life will be consumed if I process this locally? And then you just pick the easier option, the cheaper option. Again, pretty straightforward, makes sense. If you want to use less battery life, use less battery life. The problem comes in with this guesstimation. You need to create a profile of battery life consumption on your mobile device. And this is the part of my master's that took around a year and a half, where you need to measure how much battery life is consumed by your phone when uploading over this network at this signal strength, downloading at this network at this signal strength. There, I have like a stack of this many pages of just experiments that I ran to create this battery life estimation profile, consumption estimation profile. And I get like a...
Buzzword.
It's a buzzword in my field. I don't think everybody knows what that is. So that brings me to my conclusion. You can all go ahead and bombard me with questions now. I promise I know more than what is on the slides. It is technically possible to conserve battery life on your mobile device by offloading to the cloud or deciding when to offload to the cloud. But it's not feasible. Most of the times offloading is implemented on mobile devices. It is because you need to access some shared resource, a shared database, or you need access to stronger computers or services that's only available through the cloud. Which means if you need to do things locally, you need to have the entire production database of an app on your phone to do one calculation, which isn't really feasible. Any questions?
Should you compress something before sending it from a mobile device? Because it's probably quite expensive to compress. Yeah.
I don't know. Like, I'm thinking like I should go put in an addendum to my master's and just say like, in future work, I'll look into this.
You mean it's not in there already? How did you not predict the infinite possibilities of future work you could do?
Because I was so tired. Anyway, just in general, what I saw was local computation is a lot cheaper in terms of battery life than offloading, than communication. So unless the amount of data you need to communicate is minuscule, I'm talking a kilobyte at most, and what you're getting back, it's almost always better to do it locally.
Which is cool, data permitting. Yeah. So technically, yes, you should compress on your phone before sending, I'd say.
Yeah.
But we can't say that with verifiable confidence until you do your future work. More questions? Oh, Marco.
What was the comparison in time execution when you were offloading and executing it on the cloud compared to local? Was there a significant difference?
It is, again, based on the network you're connected to. I've been trying to do this on HSPA, which is 2G, for those who know the lingo. It takes about 30 seconds to upload, I think it was a 50 kilobyte file. I don't know why. My phone was just like, I'm going to take forever. So obviously then it takes a lot longer. And because it takes longer, it consumes more battery life. So the comparison, again, usually it's better to do things locally because then you're not reliant on network availability.
Hey, originally when you told me about this master, I found it really interesting, so that's why I would just like to know, was there any previous studies before yours? Because I found it interesting that in your study, you decided to rather take the worst case scenario, for example, 2G. Why not just use for your testing of your tests and all of that stuff, rather something stable like Wi-Fi, where you have like a lot of the stuff, as well as this is a two-part question. When you did make the connections, did you use WebSockets or did you just use normal HTTPS requests and stuff like that?
Okay, so in reverse order, I created a basic REST service, which when I started with this was standard fare for mobile apps calling APIs. And yes, there have been studies before. But one of the major things about that where my study differs from those is they used hardware to monitor battery life consumption or energy consumption. I used it with software, which is, if you ever go look into the Android battery life monitor things, makes very little sense. I used a third-party app for that. But in my thesis, I focused on 3G, 4G, and Wi-Fi because those are the networks that are mostly available for mobile devices, and the entire thing was this should be able to be built on the fly. My regular usage of an app that is set up that duplicates code for local execution and offloading, it should be able to conserve my battery life in that app. But before I got to that stage, I realized it's not feasible. There is no practical application for something like this, or I didn't find any.
Okay, cool. I'm just more thinking of. I do understand you wanted to just prove real life situation, but I'm actually more interested in that. Just the more like, would it actually work in a sense? So let's say we did use sockets, which means you don't need the initial connection and that kind of stuff, as well as we just used a stable connection, stable Wi-Fi. Would it have made? I probably wouldn't have made that much difference because it does sound like it was a clear-cut case. Yeah. But would it have made it?
So, in a perfect world, that would reduce the amount of energy consumed. But then you need to take things into consideration, like the phone's tendency to shut down components that aren't being used. So, even if you have the connection open, if you open a WebSocket and nothing's happening on it, your phone might reduce the power to that WebSocket, to that component, to reduce battery life. Funny, right? So either it'll still continue running at full power, which drains a lot of power because communication in general is more expensive than computation, or you will need to reinstantiate the connection in any case because your phone tried to save battery life on its own.
And then I think, as far as I understand, you did test stable connection as well as bad connection.
So
So you did a whole range.
So I did it over Wi-Fi, stable connections. I did it over 4G with as good a 4G signal as I had at the moment. Because, interesting fact, signal strength does does have an influence on the amount of battery life used, because the weaker the signal strength is, the longer the communication takes, which means the more battery life is used. So uploading a file that takes 1 second on Wi-Fi with full strength compared to uploading a file that takes 1 second to upload over Wi-Fi on the worst possible signal will consume the same amount of energy because the radio was active for 1 second.
So, in general, using a radio to offload computation doesn't work because in general your computations are too small probably to make it worthwhile, right? Like the type of stuff you do on a phone. But there will obviously be cases, probably not like real life cases, but some cases where the computation that you're looking at is so complex that you will actually get benefit from offloading it, right? Like if you're uploading an image as input to a neural network that then trains for a couple of days, something like that, right? So do you have a model maybe where you can say for a given complexity maybe or expected time to compute, like where do you draw the line or the threshold whether something should be uploaded or not?
So usually because mobile devices move around a lot, I didn't simplify it to just a single model. I took the battery life estimation profiles for the different networks and computation and modeled those. Okay. And then given past run-throughs of this method locally, this is how long it will take. Looking at the data that needs to be transferred and the current available bandwidth, determine the length of time, and then it's just a basic comparison. So I didn't take the model one level deeper.
Okay.
But it should be possible to do that, and as proof that it can decide to save battery life by offloading, I created an endpoint that, given a integer, it returned how many prime numbers there were between 1 and that number. Okay. So it sent up one integer, it got one integer back, and I wrote the most inefficient prime number calculator that I could. Well, it was in Java, Spring.
Sorry.
So, and in that case, I think only on the worst 3G connection that'll take that long, it suggested offload it. Like on the worst 3G connection, it would say do it locally, but in most cases it'll say offload it because it's so little communication, and while you're waiting, your phone's not doing anything.
What I would like to ask is, isn't it better to find a balance in between cloud and local by user preference? So for instance, some people are very into social media and want the latest, the greatest, like now. But some apps take a while to finish their process. So like let's say using Google Maps. So in the option where Google Maps give you the ability to send the directions to your phone, in the sense of like the local consumption, when in those cases be much better to have that locally because it's a set route. I mean, you're going from A to B, and where someone that doesn't use Facebook a lot can say like, okay, bundle like a download every 3 hours, something like that.
So you can do that, but then you need to take more things into consideration than just user preference. Like from the server side, calculating all the changes every 3 hours for Facebook, and then sending that down is more expensive than just, as soon as you open the app, requesting those changes. So you can conserve battery life, but I don't think, like, that's not something you as end user can do. It would have to be on, like, from Facebook's side, if that makes sense.
Last question. Do you foresee any apps or services using this in the near future? So like, let's say WhatsApp or Google Maps, something, like utilizing this service in the apps in the near future?
So Google Maps, I think, is one of the examples of things that can actually do this. Because you can, excluding for up-to-date traffic, you can have all the information required to get you from point A to point B on your phone. So something like WhatsApp, you can't do that because the whole thing is you need to be instantly connected to another person. And if that's only locally, you're not connected to anybody. Yeah. So in the majority of cases, you can't do this because most apps have a shared database on the server with more data that can be stored locally. So you can't do the necessary computations or calculations locally because you don't have the necessary data, which is what I was trying to say in this second sentence here, for those of you who thought I can't English. It's iffy.
Cool. So thank you very much, Herman. Round of applause for our masters, guys.